Welcome back to Mastering C++ 20 Features. In this lecture, we will look at the terse syntax for generic functions. With the terse syntax, we get the ability to use a concept and constrain the template parameters in a generic function without using the requires clause or requires expression. The only prerequisite is that the constraint is already defined. Let's see this in action. So far, we mostly defined a named concept and used it to constrain the template parameter with the requires clause. But with the terse syntax, we don't even need to use the requires clause. The constraint can be directly applied to the template parameter within the angle brackets and used in place of the typename keyword. Terse syntax can be used with our handcrafted concepts and with the standard concepts alike. And I've shown examples in generic functions, but it can be also used with class templates as well. Here on the top, we have the same named concept, numeric type, and arithmetic type that we saw in the previous lecture. The arithmetic type concept here is commented out, but it is provided in the header 07 shape.hpp that I gave out in the previous lecture. In line number 27, we can see that the concept arithmetic type is used to constrain the template parameter directly within the template declaration. And similarly, in line number 34, the concept numeric type is used to constrain the template parameter v for the add1 function. And in both the cases, there's no need to use requires clause anymore to constrain the template parameters. Also in line number 41 and in line number 47, we see two overloads of the same function do something with numbers which have two template parameters, number 1 and number 2. And in both the cases, the template parameters are constrained differently. In one of them, the template parameter is constrained to have only integral numbers, and in the other one, the template parameter is constrained to have only floating point numbers. If we look closely at these functions, we can see because of two template parameters, number 1 and number 2, these integral or floating point values can be of different type. For example, in the first overload, one of the template parameter can be of type int and the other template parameter can be of type unsigned int. And similarly, in the second overload, one of them could be of type float and another one can be of type double. But if we want to specify additional constraint on the template parameters, say for example, the two template parameters are of the same type, then we can specify an additional requirement in the function declaration by an additional requires clause or expression that we've seen earlier. In this case, one way of specifying the additional requirement would be using a requires clause with the standard concept std same as, either before the function declaration or as a trailing requires clause. Let's see how. In the first one, I can use a requires clause before the function declaration, and here I'll say requires std same as the two template parameters, number 1 and number 2. And in the second function, I can apply the same requires clause but as a trailing requires statement. In the end, we can see the terse syntax can also be applied to class templates. Here I have shown some example of usage, and I'll upload this file with the lecture. So that's all I wanted to talk about in this lecture. See you in the next lecture. Thank you.